So today we're going to be talking about section 13.5 or 3.5, depending on the book that we're looking at. And we're going to be talking about today different types of probabilities called independent or dependent probability. Now, we've looked at these probably before in previous classes, but we're going to look at them again. All right, so a compound event is when two or more things are happening at one time. Sometimes we call them composite events. And they're just simple, easy events that happen. Okay. And in the book, there's an example where it says there's like 10 kids in the class, right? And so James and Arturo have to be chosen to to present their project, right? And so what's the probability of James being chosen and then Arturo, right? So the probability of that happening, well, James is just 1 out of 10, right? And then what happens is Arturo, if we don't replace that 10, right? If James is done, there's only 9 kids left, and that would be 1 out of 9. And so what is the probability that they would be chosen in that order, right? And so we can look at that event, and we're going to look at those different types today. Okay, so the first thing we're going to look at is independent. So independent events are when the probability of the first thing happen does not affect the probability of the second thing happening. So a good example of that would be like if I was drawing a card. So let's say we're looking for the King of Hearts, right? Looking for the King of Hearts. And then I'm going to roll die, or a dice. I guess roll die, right? And so then I want to try and get a 4, right? So the chances of getting King of Hearts or getting a 4 do not depend on each other. Okay, that's called independent. Dependent events are when probability A can change the outcome of probability B happening. So an example of that would be like if I'm drawing a card, right? And let's say I'm taking that King of Hearts again. And then the next time what happens is now I want to draw the Queen of Diamonds. But you'll notice that my chance of picking a Queen of Diamonds on the second card, if I don't replace the first card, actually gets a little bit better, right? And so instead of 1 out of 52 for the first time, it's going to be 1 out of 51 for the second card, all right? And so basically the rule is if you replace the object, it's going to be independent, right? Or if you don't replace the object, they're going to be dependent. And we'll look at a couple examples here coming up. Now, let's see if we can tell the difference between them, okay? So in example 1, it says determine whether the events are independent or dependent. It says a coin is tossed. Okay, so let's say we're going to try and get like a heads the first time. And then the next time, the chance of tossing a second coin. Well, I could also get heads again. And my chance of getting a second heads is not affected by my first flip. So this is an example of independent events, right? Because getting a heads on the second one is no different than getting a heads on the first one. So those are independent events. Let's look at the next one. It says in the class presentation, one student's name is chosen and not replaced. Then a second's name is chosen. So that's like our example of James and Arturo, right? So James was 1 out of 10, where Arturo was 1 out of 9. And you'll notice the probability changes based upon how many students are left in the class. This is an example of dependent events. And maybe you picked up on that when we were talking about it, but that's dependent events right there, okay? And then the next one, it says Wednesday's lottery numbers and Saturday's lottery numbers. So the chance or probability of picking the lottery numbers on Wednesday is 1 out of like 4.8 billion or something like that. And Saturdays is the same thing, right? The chance doesn't change. And so these are independent events. And actually, there's an interesting episode of Numbers where they're talking about lottery. And one of the things they said is they did a study in California and found that the most common 5 numbers chosen for the lottery are 1, 2, 3, 4, 5, right? So the chance of that being chosen is actually the same as the chance of any set of numbers 1 through 36 being chosen as well. So kind of interesting, but that's independent. Those are independent. So here's a couple guided practice problems that you can go ahead and try now. Okay, so suppose a coin is tossed and a spinner is spun. So the chance of getting heads in blue, heads in red, heads in green, or tails in blue, tails in red, or tails in green right, are a sample space, right? And so you'll notice the chance of picking a heads is 1 out of 2, right? Or tails is 1 out of 2. And then picking green or any color is 1 out of 3. And so the way we find the probability of them both happening, it's actually 1 out of 6, right? A heads and green is 1 out of 6 in my sample space. So that shows that the probability of two independent events, if you want them to happen, you just multiply the probability of the first times the probability of the second, right? So let's look at a couple examples, right? And so it says right here, Marisol and her friends are going to a concert. They put slips of paper in a bag shown. So here's our slips of paper right there, okay? And so it says that if someone picks a yellow, right, yellow, that is when you're going to ride in the van to the concert. And there are 1, 2, 3, 4, 5 yellow, okay? Then if you pick a blue, you get to ride in the car. Yep. And so blue, there are obviously 1, 2, 3 of those. So there's 3. So you can see that there's a total of 8 different things that are going in the bag, right? So now it says, suppose Marisol draws a slip, not liking the outcome, she puts it back and draws a second time. What is the probability that that each one of her slips is a blue? So we're looking for the probability of blue, we'll call it B, and then blue again, all right? So the probability of picking up, well, there's a total of 8 of these, right? Okay, together there's 8. So the probability of a blue is 3 out of 8, right? But then she doesn't like that blue, and so she puts it back, and she draws again, and again, the probability of picking blue is 3 out of 8. So the probability of this event occurring is 3 times 3, which is 9, and 8 times 8, which is 64. So 9 out of 64 is the probability of them both being blue. Now, let's assume that they both were yellow, okay? Probability of yellow and yellow, right? And so when I do that, what I end up getting is, okay, yellow and yellow would be 5 out of 8 times 5 out of 8. That's actually 25 out of 64. So that's an even better probability if we were looking at it to see them both being yellow, right? That's a greater chance of that happening. Now, you'll notice this is 9 here, and this is 25. And so together that's 34. So what's up with the other 30 out of 64, right? Well, think about it. What's up with the other 30 out of 64? That is the probability of them being blue and a yellow between the two of them. Now, it doesn't separate yellow then blue or blue then yellow for this probability, but we could figure that out, and we'll talk about that later. But for today, we're just going to talk about this, okay? Now, what happens if we have two dependent events? So in that one, they were independent because there was the same number, 8 slips both times. Well, when we're looking at two dependent events, we have this. The probability of A and B occurring would be the probability of A times this one right here. And this means the probability of B happening such that A has already occurred, or the probability of B after A has happened. And they're conditional probabilities. That's the special name that we have. And it looks a little goofy, but it'll make more sense in a problem that we're going to look at next. So it says, in example 2, okay, we're referring back to that one. So remember that there are 5 yellow, right? 5 yellow, and there are 3 blue, right? Here we are. We're picking blue and yellows again. So it says, okay, it says, suppose Marisol draws a slip and does not put it back. Then her friend Christian draws a slip. What is the probability that both friends draw a yellow? All right, so we're looking at the probability of yellow and yellow again, right? But now this time they're dependent. So the chance of picking yellow the first time is that 5 out of 8 number that we would have known from the last one. Now, one of the yellows is gone, right? Marisol picked it. And so now there's only 7. So her chances of drawing a yellow again, Christian's chances, would be 4 out of 7. And so when we multiply that together, that's 20 out of 56. And so we can actually, you could simplify it, but we'll just leave it as 20 out of 56. Actually, let's simplify it, and we'll just talk about it. You can take 4 out of both of them, and so that would be 5 out of 14. And so the chance of it happening is 5 out of 14 in that sense. But look, in the problem above, the chance of 2 yellows was 25 out of 64, which would be, if we look at a calculator, 25 out of 64, that is 0.39, or the other one was 5 out of 14, which is 35%. So the chance of them both being yellow without replacing is actually better than the chance of them both being yellow without replacing, actually. Okay. All right. So interesting, right? So here's an example using cards, and notice that we are not replacing cards, and I want to know what the probability of getting this hand right here, both diamonds, would be. Now we have something called conditional probabilities. It says that when you're finding the probability of 2 or more dependent events, conditional probabilities can be used when additional information is known about an event. All right, so it says, suppose the die is rolled, and it's known that the number rolled is going to be odd. What is the probability that the number rolled is 5? So basically it's saying, what's the probability of rolling a 5 given that we know it's an odd number? And so that would be 1 out of 3, because our odd numbers would be 1, 3, and 5. 5 is 1 out of the 3, right? So it'd be 1 out of 3. All right, so let's look at some. All right, so it says right here, Miss Fuentes' class is holding a debate. The 8 students participating randomly draw cards numbered with consecutive integers from 1 to 8. Students who draw odd numbers will be on the proposition team, and students who draw even numbers will be on the opposition team. If Jonathan is on the opposition team, what is the probability that he drew a number 2? All right, so look right here, even numbers. So on cards from 1 to 8, there is the even numbers 2, 4, 6, and 8. So there is a total of 4 of them, right? So 4 total. Now, what is the probability that he chose the number 2? Well, 2 is one of my options, right? So he chose 1 out of 4 total. So 1 out of 4. So the correct answer for this one is B, right? So here's a guided practice problem that also talks about that. It says when 2 die are rolled, what is the probability that 1 die is a 4, given that the sum of the 2 is 9? So we got to think about all the ways we can get 9 between 2 die. So there's not an 8. There's not a 7. There's 6, right? So I can have a 3 and a 6, right? I could have a 4 and a 5. I could have a 5 and a 4, or I could have a 6 and a 3. Those are the 4 different combinations that add up to 9. So it says when 2 die are rolled, what is the probability that 1 die is a 4, given that the sum is 9? So we think of how many total ways we can get 9, 4 ways, and how many different times do we see 4 as an option? 1 and 2 of them, right? So there's 4 total and 2 times. So what's the probability of that happening? I'll let you figure that out now. Okay, so that's what I have for independent and dependent events. Hopefully it wasn't too difficult. And if you have any questions, let me know. Otherwise, I think you're ready for your assignment now.